Okay, so today we're converting a decimal into a fraction, and also a fraction into a decimal. Okay, fraction into a decimal is actually what we're really doing, sorry. So, again, here's what I want you to actually remember from today's lesson. When you take a decimal and turn it into a fraction, it's basically about the one with the zeros after it. Okay, so 0.1, that's 1/10, because that's in the 10th spot. 0.1793, that's thousandths, right? No, it's not, it's 10 thousandths. So that's one with 4 zeros after it. So the number of digits after the decimal point is the number of zeros. So then to turn a fraction into a decimal, basically what you need to do is, let's say you got 1/4, you need to change it so that there's a 1 with some zeros after it at the bottom. And so it's basically a matter of knowing your times tables fairly well and knowing that to get from 4 to 100 you need to multiply by 25. So you do the same thing on the top and you multiply by 25. And then that would be 0.25 because there's 2 zeros, so there's 2 decimal places. Okay. So let's do that. 0.123. So there's 3 decimal places. So the bottom is a fraction with 3 zeros. And then the top is 123. And that's it, right? Now we could try and simplify the top and the bottom, but I know that there's no common factors between 123 and 1000. Right, the bottom is always tens. So tens, it's 10 times 10 times 10. And if you did the prime factorization, that's going to be 3 2s, oops, and 3 5s. So there's nothing in common there between that and 123. So the next one also has 3 decimal places. I very much prefer improper fractions, which is what that is, to mixed numerals, which is what that is, for a few reasons, including the fact that they're easier to put in your calculator, but also they're just easier to do everything with, adding, subtracting, dividing. It's just easier for everything. Okay, but again, what the purpose of this one is to show you that it doesn't matter if there's numbers in front of the decimal point. All that matters is how many there are after the decimal point, and there's 3. So the same here. There's only 2 numbers after the decimal point, so the denominator will just be a 1 with 2 zeros. Not 3, not 5, not 27, 2. And again, I prefer mixed numerals, so I do 1201 on the top. So you could do that as well if you wanted, but mixed numerals for me always win. Okay, so that's kind of the easier half. The trickier bit is going from fractions into decimals. How do I do that? Well, again, like I was showing you before, so this one's already done because it's 1s and 0s on the bottom. There's 1 0 on the bottom, so there's only 1 decimal point. Easy, right? There's 2 zeros on the bottom, so there's 2 decimal points. Easy. There's 2 zeros on the bottom, so there's 2 decimal points, and the number on the top is just 3. So you kind of start the 3 at the back, like that. Right, so you put the 3 at the back, and then you just put as many zeros in front as you would have needed. In this case, 1. So another example over here, let's say I had, 7 divided by, let's just be ridiculous, 1, 2, 3, 4, 5 zeros there. So I need 5 decimal points. So the 7 needs to be the 5th number. 1, 2, 3, 4, 5. Okay. How many zeros? How many numbers after the decimal point? 3 zeros. 3 numbers after the decimal point. 2 zeros. Only 2 numbers after the decimal point. But there's 3 numbers, so it goes there. And that makes sense. 192 divided by 100 is more than 1, right? It's 1 and some leftovers. 37, but there's 3 zeros, so I need a 0 in front. So give me 3 decimal points. Now we start getting a little bit trickier. Okay, so I need to work out what goes on the bottom. So I need a 1 with some zeros after it, right? However many I need. And it's basically just a matter of looking at what you've got and working out the patterns. So with 5, that's a fairly easy one, because I can just multiply it by 2 and get 10. Now I can't change the top. I have to do the same thing to the top and the bottom, and that gives me 32. Hopefully you're starting to see why your times tables are so important. One number after the decimal point, 10, 3.2. Next one, 3/4. Hopefully you know 3/4 is 0.75, right? Hopefully you know that. But what do I multiply 4 by to get a 1 with some zeros? And again, you just need to know basically that 4 lots of 25, you need to be able to spot the pattern. 4 lots of 25 is 100. So 3 lots of 25 is 75. So notice the 5 at the bottom, back here, I multiply to give a 10. A 4 at the bottom, I multiply to give 100. I'm kind of doing all the common ones for you, right? The next one is an 8 at the bottom. Now, hopefully you remember the starter question. And I did 200 divided by 8. The reason I did that is because now you know that 8 times 25 gives 200. All right, this is one that you should basically just remember as a strategy. And again, as always, same thing to the top and bottom. 5 lots of 25 is 125. And what about a mixed numeral? So a mixed numeral, you can kind of just ignore the 1, right? So I know my answer is going to be 1 point something, and I just need to work out what that something is. So all I'm really worried about is this 5 on the bottom. And what do I multiply it by to get a nice number on the bottom? Just shove the 1 there, leave that to the end. And 5 times 2 is 10. So the 2 times 2 is the 4. Now, notice I did not multiply the 1. Right? I didn't multiply the 1 because you didn't change the whole number bit, right? So you don't have to unchange it, as it were. The reason you multiply the top and the bottom is because if you just change the bottom of the fraction, you change its value. Right? It's like you've got a pizza and more people arrive. Suddenly you get less of that pizza. So if you change the bottom of the fraction, you must also change the top. Again, the 1 just goes there, and it's 1.4, one number after the decimal point. And you should just do your kind of silliness check. Does the number size 1.4 remind you of the number size 1 2/5? It should. Right, it's 1 and a bit, 1 and a bit. So I need to just quickly talk to you about repeating decimals now, and particularly the notation. So this thing here means it's 0.2, and the 2's go on forever. So you just keep writing 2's forever. So these are repeating decimals, as opposed to these ones up here, which are terminating. So the quickest way to do this is to just put a dot over the top of any number that repeats. And if there's more than one number that repeats, as in the second example, you can do a few things. Personally, I do that. It's the quickest, easiest, and least cluttered. So a dot over the start number and a dot over the end number. You could also put a dot over the 3 numbers that repeat. That's the same. And you can also put a line over the top of them. That's the same thing. I should probably also show you this example. So let's say I had that. Well, that's 0.19 with the dot only over the 9, because the 9 is the only thing that repeats. Okay. So let's convert some more to decimals. So 1 into 3. Now, you can try anything you like. You can multiply the top and bottom by 3 and you'll get 3/9. It's not correct because there's no 10 on the bottom. Right? So when you can't work out the number to multiply the top and the bottom by, this is what you do. So this is the same 1 over 3 is the same as writing 1 divided by 3. So you just do 1 divided by 3 like this. Notice I've left a lot of space there because what I'm going to do is I'm going to add some decimal points basically until it's finished. And you'll see what I mean in a second. So 3 into 1, 0 times. Line up the decimal points, carry the 10. So carry the 1 to make it 10. 3 into 10, 3 times, remainder 1. 3 into 10, 3 times, remainder 1. 3 into 10, 3 times, remainder 1. I'm getting bored of saying this. 3 into 10, 3 times, remainder 1. So hopefully you're noticing that this is just going to go on forever and ever and ever. And so this is the repeating decimal, 0.3 recurring. Okay. I'll show you another one with a pattern, and then I'll show you one of these for something that doesn't have a pattern, like up there. Oh, I didn't finish this, did I? Sorry. I think I got distracted by my dog. She was being naughty. So I'll go back and finish this later, all right? And then I'll do it the other way. Sorry about that. So 5 into 6, so that's the same as 5 divided by 6. Again, I'll tell you now, there's no way you're going to answer it any other way. So 5 divided by 6. 6 into 5, 0 times. How many times does 6 go into 50? Oh, now we're testing out my tired brain. At the start of the week. So I think 6 goes into 48 nicely, doesn't it? Yes, it does, Dr. Manuel. Well done. Thank you. Goes in 8 times. Remainder 2. 6 into 20. 3 times. Remainder 2. Uh-oh. 6 into 20. 3 times. Remainder 2. 6 into 20. 3 times. Remainder 2. And once you start to feel like a broken record, you can stop. Because you know you found the pattern. 0.83 recurring. We'll do 2 more. I'm also going to do 2 sevenths later. Okay, so let's go back to this one. I didn't finish it, did I? I need a 1 with a lot of zeros at the bottom. Multiply by 5, multiply by 5 to make it thousands. 125 divided by 5 is 625, so that's 0.625. Now, let's say I couldn't work that out myself. That's okay. What I can do instead, and I'll switch pen color so it's obvious that it's different, is I can do 5 divided by 8. So 8 into 5, 0 times, carry the 5. 8 into 50, well, that sounds very familiar to me, goes 6 times. That gives me 48, remainder 2. 8 into 20, 2 times, remainder 4. 8 into 40, 5 times, no remainder. No remainder means I'm finished, right? So that makes it 0.625. So that's how one of these works if it's not a repeating or recurring decimal, I should say. Right? Repeating, recurring, same thing. So let's go back to the 2 sevenths. So I'll tell you now that you have to do 2 divided by 7. There's nothing nice you can multiply 7 by to get 100 or 1,000 or whatever. And I'll tell you now it's going to be a recurring decimal, isn't it? So carry the 2. 7 into 20, well, it's almost 21, so it's 2 times, remainder 6. 7 into 60, that's 49.56, so that's 8 times, remainder 4. 7 into 40, that's 5 times, remainder 5, 35. 7 into 50 is 7 times. Remainder 1. And we're just going to keep going until we spot the pattern. I haven't spotted it yet. The easiest way to spot the pattern is to notice when the remainder changes. Because you know how I'm going like 7 into 20 here? So then you get 2 remainder 6. 7 into 60, 8 remainder 4. Now if I then said 7 into 60 again, I'm going to get 8 remainder 4, aren't I? Every time. So basically you're just looking for the remainder to repeat itself at some point in time, and then you know the pattern is just going to go on from there. So 7 into 10 is 1, remainder 3. 7 into 30 is 4, which is 28, remainder 2. And now I'm back here. So what's going to happen next? I'm going to say 7 into 20, which is 2, remainder 6. And then I'm going to say 7 into 60, which is 8, remainder 4. And I'm going to say 7 into 40, which is, and I'm just going to go on like this forever. And so this bit is going to repeat. And then it's going to repeat again, and then it's going to repeat again, and then it's going to repeat again. And it's going to go on forever. And so the answer is 285714 with a dot at the start and a dot at the end. Or a line across the top, or a dot over every number, whatever you like. But my way's the best, so do my way. Okay? That's a pretty challenging one, right? It's long enough that you kind of think to yourself, there's probably not a pattern appearing, and then all of a sudden it appears. Okay, so be persistent, don't give up. Right? Any longer than that, that's 6 decimal places. I'd say if you're getting to 8, there's probably not going to be a pattern, right? But basically, that's the idea. Okay, homework is here. You must OneNote it, please, or submit it in some way. And it's not homework, it's work to do in class today. So you've got 45 minutes to watch my amazing videos, take notes on them, and then do what you can of those questions and submit that to your teacher after that. Okay, thanks girls, take care.